Okay, let us start the new important proof, I can say. See, what happens, we know that whenever suppose you take y is equal to f of y is equal to 1 over x, if you take curve here, as x tends to infinity, the y tends to 0 here. See some constant. Uh, uh, the point P on a curve, whatever x tends to infinity, the y tends to some constant. Then what we are telling, y is equal to c is an asymptote, we are telling. This is very important. Means y is equal to 0. Example here, y is equal to 1 over x. As x tends to infinity, y is equal to 0. Therefore, we can say that y is equal to 0 is the horizontal asymptote. Okay. In the similar fashion, if suppose y is equal to mx plus c, if I say asymptote to the f of x, then as x tends to infinity, the y approaches mx plus c. Therefore, the limit of y minus of mx plus c as x tends to infinity is equal to 0. The distance tends to 0. It means that if I say y is equal to mx plus c is an asymptote, according to see here, y is equal to c is y is equal to 0 is an asymptote. As x tends to infinity, y is equal to tends to 0. In the similar fashion, if I say y is equal to mx plus c is an oblique asymptote to the f of x, as x tends to infinity, whatever the y coordinates of that curve approaches mx plus c, it means that the limit of y minus of mx plus c as x tends to infinity is equal to 0. It means that if you as x tends to infinity, y is approximately equal to the mx plus c. It means that if you divide by x, then y by x is equal to mx plus c. M plus c by x, as x tends to infinity, this y by x is equal to limit of y by x is equal to, I can say that m. It means that as x tends to infinity, see here, the curve almost touches the line. Almost not touches the line. The line, whatever the y is equal to mx plus c, act as a tangent to the curve at the infinity. This is very important. It means that whatever the slope of the line, that is a slope of the given line is m here, and slope of the curve is equal to dy by dx. We know that whenever if you draw a curve and I can say that the slope of the curve at a point is equal to slope of the tangent at that point, isn't it? Therefore, the slope of the line is m and the slope of the curve is dy by dx. Since the line acts as a tangent at the infinity, the slope of the curve at infinity becomes the slope of the line. Therefore, dy by dx, whenever I can say that at the infinity we're going to touch us here. At the infinity, the curve will going to, I can say that it almost touches, not almost, I'm telling that. At the curve infinity, the curve will going to almost touches the uh, line. Therefore, at infinity, the y is equal to mx plus c becomes tangent at the infinity. At that point, act as a tangent means the, I can say that the slope of the curve at as x tends to infinity becomes slope of the tangent. This is very important. Two things we observed that the asymptote means distance becomes 0, and we are going to say that limit of y by x as x tends to infinity becomes m, and geometric view the line is tangent at the infinity, and consequently the limit of dy by dx as x tends to infinity is equal to m. This is a very important understanding or concept. Two things. whenever I can say that as the variable point on a curve, we may take with a, in the previous classes we studied as x tends to infinity. Suppose if you take a point on a curve, x comma y is x tends to infinity, whatever the y value tends to some constant, that is the asymptote y is equal to. In a similar fashion, if suppose if I say y is equal to mx plus c is an asymptote to the curve, as x tends to infinity, the whatever the y coordinates of the curve must approaches mx plus c. According to mathematically, you can say like that. It means that it means that if you divide by both the sides on x, what happens? Y by x is equal to m plus c by x. Then it means that limit of y by x as x tends to infinity is equal to m. This is the one thing. And we know that whenever the curve is there at as x tends to infinity, the y is equal to mx plus c act as a asymptote, means it will going to touch at almost touches at the infinity, becomes almost tangent at the infinity. Once it is tangent, we know that slope of the almost touches means the I can say that the slope of the curve at infinity, the point is whatever the point we taken is at infinity. The slope of the curve at a point infinity is equal to the, because we know that whenever the slope of the curve at a point is equal to the slope of the tangent drawn at the point here. The slope of the curve at the point of infinity is equal to the slope of this line, that is m. Therefore, you can say that the limit of dy by dx as x tends to infinity becomes equal to m. This is a very important concept you should understand. Thank you.